Hi, I'm Caitlin Catoni and welcome back. In this video, we're going to talk about how to write correct ionic formulas when we're given the ions to start with. This video is appropriate for introductory chemistry, general chemistry 1, and any level of high school chemistry. Before we get going, let's remind ourselves of a couple of things. First of all, we have to remember what a ratio is. A ratio is just looking at how many of something there is in comparison to another. For example, if you happen to be an only child and you live in a family with two parents, there's one of you and two of them. So, one child to two parents, that's a ratio. We also need to remember what ions are. And we're going to use some nomenclature here. We're going to name positive ions cations. A negative ion is going to be an anion. We also have to remember that positive ions and negative ions, they cancel each other. Just like how in math class, positive numbers and negative numbers cancel each other. The final thing that we need to recall is the different ways to write ions. I've given you 3 examples down here. I tend to go with the first one. This is how I usually write ions that have a +1 charge. I don't actually put the 1 there, and that's fine. If you prefer to have the 1 there, then you could also write your ion this way. And in some cases, some instructors are okay writing the ion with a +1. It depends upon how specific your instructor wants to be with ions, because technically an ion is written as a 1+, whereas something else called an oxidation number, which you may not have learned yet, is written as a +1. So it depends on the level and it depends upon what your professor would like to see. So make sure you know which one of the ways to write ions is appropriate for your class. Let's look at our first example. Here in this first example, we're going to start with one of the easier examples and then ramp up the difficulty as we go along. So let's look at how potassium is a +1 and chloride ion is a -1. Like we said earlier, positives and negatives cancel each other. So what we're going to do is see what's the ratio, how many of each ion we need in order to cancel out the charge so that there's 0 overall charge. For this one, it's pretty straightforward because a +1 cancels a -1. So you need 1 potassium and 1 chlorine. So you just write the 2 element symbols right next to one another. You don't need anything else. Let's ramp it up in level of difficulty and see where some more issues can arise. So let's change our ion. We changed our cation from a potassium ion to a magnesium ion. So now we have a magnesium ion, which is a magnesium 2+, and chlorine is a 1- still. So again, our search is for, can we find the ratio between magnesium ion and chloride ion that ends up canceling out the charges so that there's an overall 0 charge. We call that a net 0, right? Net means overall. And so when we look at this, I like to just draw another chloride because I think it helps people visualize that 2 chlorides end up adding up to a 2- charge. 1 magnesium is your 2+. So I need 2 chlorides for every 1 magnesium. That's our ratio. How do I write that in a chemical formula? So I'm going to write the Mg, the symbol for magnesium. We only have 1 of them, so we just write Mg. Then I'm going to write the symbol for chlorine. We have 2 chlorines, right? Here's 1, here's 2. We need 2 chlorines for every magnesium. The way that we indicate that we have 2 chlorines is with a subscript. You don't have to make your subscript another color. I just think it's helpful here. This example is a little bit harder, and I'm actually going to show you 3 different ways to address this particular problem where it gets a little bit harder to see what the ratio is between the two ions. So one way to start this is to look at the two ions that you have. And remember, I've got a +3 for aluminum and I have a -2 for oxygen. Notice how aluminum here is odd. That's an odd number. A lot of times it can be really helpful to start by doubling the ion that's odd. And so that means I'm going to write in another aluminum and say, okay, this one adds up to 6+. So now that this one, the aluminum, I'm not dealing with an odd number anymore. I can then look at my oxygen and probably get a better idea of how many oxygens I need for every aluminum. I have a 6+ for all of my aluminums together, and now I need to figure out how many oxygens I need to cancel out that 6+. So it's much easier to figure out how many oxygens we need once we don't have an odd number to work with. So how many times does 2 go into 6? That's the real question we're asking, because we want to focus in on the fact that we have a -2, and we want to figure out how many times that -2 needs to be multiplied by in order to get to a -6, because our +6 and our -6 need to cancel. So our goal is to get to 6-. So how many oxygens do we need? Well, we already have 1. What if we add another 1 and a third 1? That gets us to a 6-. The way to then write this in our formula would be we write the aluminum, the chemical symbol for it. We have 2 aluminums, so we need to write the 2 subscript here. Then we have an oxygen, but we don't just have 1, we have 3 of them. So the fact that there's 3 oxygens needs to come in with the subscript that immediately follows that element. So this is one way to go about it. The other way is using the least common multiple from math class. So let's just remind ourselves what the least common multiple is. The least common multiple is when you look at 2 numbers like 2 and 3, and you see what they have in common. For example, if I multiply 2 by 1, I get 2. 2 by 2, I get 4. 2 by 3, I get 6. Then I'm going to do the same thing with 3. I get 3, 6, and 9. So what do they have in common? They have 6 in common. So this is why in the last example, which was still aluminum oxide, we were trying to get to 6. We really hadn't just put a name to where we got 6 from, and that 6 is just using the least common multiple. So the least common multiple of 3 and 2 is 6. So if I focus in on the fact that I have aluminum 3+, I know that I need to get to the point where I get to a 6+ because of the least common multiple. For oxygen, I focus in on the fact that I have a 2-. I know from the least common multiple that 2 times 3 is 6, and so I'm going to use the fact that I have 3 oxygens to get me to 6-. And so this way, although I like this way more, usually students don't, because it involves a lot more thinking, and so it depends upon where you stand and I guess how much you love math. I love math. So let me show you the trick that a lot of high school teachers show their students that I really dislike showing my students, but I'm going to show it to you anyway. And I'm going to call it a pitfall. Why? Because even though it looks like it's a beautiful, beautiful, beautiful thing and it always works, it doesn't always work. So I want to show you an example of where it works and then show you an example of where it doesn't. So here, this as the same example of aluminum and oxygen. When you have aluminum and oxygen, or anything where you can't easily see how the ratio is supposed to be set up in order to get the charges to cancel, then what you can do is you can focus in on the charge, but without the positive or negative, right? So I just circled the 3 and the 2. And then you can take the 2 and you can bring it over here as a subscript. And you can take the 3 and you can bring it over here as a subscript. And you get Al2O3. That's the same thing that we got the last 2 times we worked on this problem. Now, it's really automatically doing the least common multiple for you, because what it's saying is I'm taking the 3 plus and I'm multiplying it by 2, and I'm taking the 2 minus and I'm multiplying it by 3, and I get a positive 6 and a minus 6, and those cancel. And so it's taking all the thinking out of doing the least common multiple. It's a really helpful tool if you know when to use it. You can absolutely use it in this example. Let's show an example where it's not going to be as successful. If we have something like tin 4 plus and oxygen oxide 2 minus, and we go through the crisscross method here where we take the 4, we put it down here as the subscript, we take the 2, we put it down here as the subscript. Then what will happen is you'll get SN2O4. So why is this a problem? Because notice how you can actually take the 2 and the 4 and you can reduce that ratio, right? A 2 to 4 can be reduced to a 1 to 2. And when we write ionic compounds, we're always writing the smallest ratio. And when I say smallest, it's also a whole number, so don't go into fractions or decimals, right? So smallest whole number ratio, meaning that our correct answer should be SnO2. So if you can remember to double check and reduce your coefficients, then you can get away with the crisscross method. It's not a super safe method if you can't remember to double check. The other thing that scares me about the crisscross method is later on, you're going to learn how to go kind of backwards, right? If I give you SnO2, you're going to tell me what the charge of tin is, the Sn. And if you then automatically do backwards crisscross without engaging your mind, then it's really a dangerous thing to do on exams. So I just want to show you this with hesitation. As always, thank you for watching. If you found this video helpful, hit the like button and also subscribe. If there's another video that you'd like to see, let me know in the comments below.